the differences between Sn1, Sn2, E1 and E2. As far as concerned with with our cyclohexane stereochemistry, we need to study some substitution reactions in cyclohexane and elimination reaction in cyclohexane and its stereochemistry. What will be the stereochemical outcome of the elimination reaction on cyclohexane stereochemistry, and what will be the stereochemical outcome of the cyclohexane chemistry after Sn1 and Sn2 reaction. So first of all, we will let's clear our basic concept about Sn1, Sn2, E1 and ut2. Okay, so some things you might know since our 11th standard study about Sn1, Sn2, E1 and E2. So we will let's revise in another way. Okay, so concept of Sn1, Sn2, E1 and E2. Here I have written Sn1, Sn2, E1 and E2. Okay, so I made one table in which we will summarize. So how different parameters we will apply for the Sn1 reaction, Sn2, E1 and E2 reactions. Okay, so first we will start from the Sn1, Sn2. Okay, so one thing I wanted to tell you initially. So out of this Sn1, Sn2, E1 and E2, the Sn1 and E1 reactions, they are resembling. So okay, so many parameters. Sn1 is resembling with the E1 in so many parameters, and Sn2 is resembling with the E2. So nucleophilic substitution reaction, unimolecular, that one is resembling with the unimolecular elimination reaction, and bimolecular nucleophilic substitution reaction in alicyclic system, that one is resembling with the elimination bimolecular elimination reaction in different parameters like solvent, like what base needed, or what, or rate law, or some starting materials, in which type of starting materials needed. So these some parameters they do match with these two. Okay, some parameter they do match with these two, and some parameter they do match with these two. So let's see one by one. So first one, Sn1 reaction. So as you know, is Sn1 is indicating that this is unimolecular reaction. So I will write here the first one is, we will go for the rate law. What is the rate law of Sn1, Sn2, E1 and E2? So in case of Sn1, you can see here, this is unimolecular reaction. Okay, so I have written here already, but it's not visible, so I am overwriting that one. So Sn1 is unimolecular reaction. The same with Sn2. So this is Sn2 represent, this is bimolecular reaction. Okay, so we will go first step by step. So nucleophilic substitution unimolecular, nucleophilic substitution bimolecular. Now next one about E1 and E2. So E1 is in unimolecular reaction and E2 is bimolecular reaction. So it's you know all these things. Okay, which one is unimolecular, which one is bimolecular. So now again we will go for next parameter. What type of starting materials we need for the nucleophilic substitution unimolecular? So we are going to see now what type of starting materials. Okay, so all those compounds, those should be the alicyclic compounds or acyclic compounds or alicyclic. Acyclic means all is open chain compound which possess halides. Okay, so alkyl halides. So we need starting material in Sn1 is alkyl halide. Alkyl halide. So I am taking for example alkyl halide we need in Sn1. Alkyl halide means halides group like chlorine, bromine, iodine. They can replace. I didn't say fluorine. Okay, so fluorine, replacement of fluorine is totally difficult. So I didn't say fluorine. I said chlorine, bromine. Those we can replace very easily. Okay, chlorine, bromine. So what type of starting materials we need for the Sn1 reactions? Okay, so Sn1 reaction, as you know the mechanism, so there is a formation of carbocation. So we need the alkyl halides which should be cloudy. So tertiary alkyl halide will work out faster than secondary alkyl halide and then primary alkyl halide. So you know the structure of what is tertiary alkyl halide, secondary alkyl halide, and primary alkyl halide. So what will be the now alkyl halide, what type of alkyl halide we need for the Sn2 reaction. So these things are totally contrast to the Sn2 reaction. In Sn1 reaction, we need tertiary alkyl halide will react faster, then secondary alkyl halide and primary alkyl halide will react slower in Sn1 reaction. But that is totally contrast in case of Sn2 reaction. In that one, we need primary alkyl halide that will react faster in Sn2 reaction. After that, secondary alkyl halide will react faster, and lastly, tertiary alkyl halide via Sn2 pathway will react at slower rate. Okay, so tertiary alkyl halide, that is the not good option to do the Sn2 reactions, and tertiary alkyl halide is the best option to do the Sn1 reaction. So now I have told this thing, Sn1 resembling with E1 and Sn2 resembling with E2. The same thing saying, now we will compare this one. Sn2, I will shift now. Here alkyl halide we need tertiary, secondary and then primary alkyl halide. So tertiary alkyl halide reacts faster in Sn1. The same thing with E1 here. The same thing with E1 here. Sn1, you can see here tertiary alkyl halide react faster. The same with even here also tertiary alkyl halide reacts faster, then secondary and then primary alkyl halide. Okay, so reaction rate, if it goes faster with tertiary alkyl halide, then secondary and then primary alkyl halide. And the same, I am going to repeat that one. In case of Sn2, so many parameters they are similar with Sn2 and E2, but here in E2 elimination reaction there is no any, there is no fast, we cannot say there is only fast characteristic of E2 reaction that it needs tertiary alkyl halide, secondary alkyl halide, primary. That one it will work with all type of halides, okay, with equal rate. So here we cannot say there is any need of okay, a tertiary alkyl halide, a secondary alkyl. There is no any sequence in which sequence the E2 reaction will work out in very good rate or like that. So with all types of halide, E2 reaction will work out with same rate or more or less, not that of more difference in elimination reaction bimolecular. Okay, so we are this parameter I have written here. So not no any particular parameter works out here for E2 elimination reaction. Now next parameter. Okay, now next for reaction of Sn1, Sn2, what is the second? Okay, starting material we have finished. What type of starting materials we need, that one we have finished. Now next, after selecting starting material, what is next parameter? What next thing we need? So maybe nucleophile. Okay, in nucleophilic substitution reaction we need nucleophile. Okay, so we don't need here base. Okay, I didn't say base here, but in Sn1 reaction we need nucleophile. So now what type of nucleophile we can select for Sn1 and Sn2? Okay, so we have to distinguish, no, what, okay, this one is nucleophile Sn1 reaction, this is Sn2. We are differentiating, we are making differentiation in Sn1, Sn2, because we don't want to make too much confusion. Okay, which one is Sn2, what will be the product, which one is Sn2, which one is Sn1, what will be the product. So for that one we are going to sorting out the things to decide where, okay, this is Sn1 and this is Sn2. So for nucleophilic substitution we need nucleophile. So what type of nucleophile we need? So in Sn1 reaction we need weak nucleophile. Okay, so we need weak nucleophile, and that one may be generally neutral. Okay, so what are the examples of weak nucleophile? So weak nucleophile, you can say methanol, you can say ethanol. So these are the weak nucleophiles. Okay, here are the lone pairs. So these acts as a nucleophile. Okay, so I have provided you already the list of base, list of nucleophile. If otherwise you can search by your own what are the weak nucleophiles, what are the strong nucleophiles, make list of that one and you can utilize here. So without the knowledge of which are the strong nucleophiles, which are the weak nucleophiles, you cannot decide the reactions, whether this reaction is Sn1 or Sn2. So here basic knowledge you need. what type of weak nucleophiles are there in organic chemistry and what type of strong nucleophiles. Now for SN1 we need weak nucleophile like methanol, ethanol, and now water also. You can take water also. Okay, water is also acts as a weak nucleophile. And now in case of SN2, here is also you need nucleophile. So what type of nucleophile you need? Nucleophile we need. So here if for SN2 reaction you need strong nucleophile. Okay, you need strong nucleophile. What how you can say that one is strong? So that one should bear negative charge. Okay, negative charge nucleophile. Okay, like sodium cyanide, sodium cyanide, CN,